Welcome back, everybody. We're talking about linear versus quadratic. We're going to be doing some linear regression or some line of best fit. Now, up here at the top, linear is a nice line. We should be pretty comfortable with that. And quadratic is our nice curve or U shape. You know, sometimes we can just write curve here because they'll just say curve of best fit. Let's make sure we get the equation written down in this box. In my room, it's written on the sideboard. They're not nearly as hard to memorize as you might think. If you think about the regular old line, y equals mx plus b, that we've done all year, the equation is just a little bit more robotic than that, right? So Desmos, we talked about how when you make a table in Desmos, and we'll talk about a few different ways to do that, that the table gets these little ones on the x's in case you have multiple tables. So when we write our equation down, we're just going to be putting little ones by the x's and the y's. Thank you, Ms. Gonzalez, I appreciate that. We're also going to use a squiggly line instead of an equal sign because we don't really know what that graph is equal to, and this squiggly line tells Desmos, hey Desmos, I need your help. I need you to help me find the line. Same with the equation for the quadratic. Now the quadratic equation normally scares people, but it's really not that bad, okay? Just think about it like this. A, B, C. There's definitely nothing scary about ABC. And then you're going to put an x squared on the first one and an x on the second one and no x's on the last one. That's not very hard. You're just going to put ABC and you're going to count x squared, x, no x. So when we go for our equation here, y1 squiggly line, a x1 squared plus b x1 plus c. Pretty much all the mistakes that I see have to do with these x's here, okay? Your x has to have the 1 and your first x has to have the squared. Your second x should not have the squared. These equations have to be typed in perfectly. Now, let's talk about Desmos and how we type these things in. So I just kind of previewed one way to type in a table. You can just literally type the word table, T-A-B-L-E, and that will take you straight into a table. Like I said, it's going to have X1, it's going to have Y1. There's another way. You can press the plus button and press the table, and it'll show up just as easy. Students in my class, for the warm-up, I had them go ahead and graph all of these little dots and decide whether it looked linear or not. So once I got my dots here, I could notice that, yeah, it looks pretty linear. Let's get this table into Desmos. -2, enter, 0, enter, 1, enter, 3, enter, 5, -7, -3, -1, 3, 7. I'm just copying this straight off the piece of paper that we were working on right here. Again, look at my two tables. They need to be identical. -2, -7, 0, 2. Everything looks great. Okay. Now in Desmos, I want to be able to always hit and find the perfect zoom because sometimes these numbers are very different. Remember, there's a magnifying glass that is attached to the table. So make sure you know where this is. You always want to click this button. And so when I click it, it's always going to give me a perfect zoom. A nice diagonal line. Excellent. It is really clear that this is a linear line. So let's do y1 squiggly mx1 plus b. Let's type this in. Make sure that you type it in carefully. Make sure that you type it in correctly. And once you do that, it should be looking pretty nice. Your line goes right through the dots. On the worksheet we're doing today, You don't really have the decimal issue that we had yesterday. Everything's working out very, very nicely. And you can tell how nice this graph is by looking at the r squared value. The r squared value is a perfect 1. That 1 means like 100%. If you see 0.99, that means 99%, or 0.92 means 92%. We're pretty much only working with stuff that is 95% or better. You know, maybe you'll see one that's like a 93%, but it always needs to be in the 90s. Now, here's really where most of our issues have been coming from. This is us asking Desmos for help. We're saying, Desmos, please use the table. Please use the table. This squiggly line says, please help. But the M and the B are the spots that we're giving Desmos. We're saying, I don't know what the M is, please help. I don't know what the B is, please help. And so Desmos is telling you right here what the M and the B values are. The perfect M value, the perfect B value. So where it says equation right here, we're going to write y equals mx plus b, but we're going to use the M and the B that Desmos gave us. This is the thing that the kids who aren't paying attention struggle with. Okay, they're like, I don't know where the heck that 2 came from. It comes from the parameters, but parameters is not a word that matters. The only thing that matters is that where it says M equals and B equals, that you go with them. Okay? Now, I'm going to do a little bit more teaching here. I know we finished this example. It looks excellent. What if we also tried this with a quadratic? Okay, so I'm going to go down here, and I'm also going to type in my quadratic. My quadratic formula is y1 squiggly ax1 squared plus bx1 plus c. I'm going to type all of those in just like we wrote earlier. And interesting, for this question, I also have an r squared value of 1. So I want to kind of be particular with you guys. We talked about you should probably choose the one with the higher r squared value because the r squared value is like the confidence. Desmos thinks that the blue straight line is perfect. Desmos also thinks that the green quadratic is perfect. But here's what's going on. If both of these lines are very, very good, then you always want to choose linear. Okay? For a couple reasons. First of all, linear is just a little bit easier. Okay? You have M and B, that's it. You don't have any squared terms. For down here, the quadratic, you got A, B, C. It's a little bit extra, and you got the squared stuff. If they both look very good, you want to use linear. The other reason is basically if the quadratic graph looks good enough like a straight line, you might as well just use a straight line. The quadratic is supposed to be a curve. If the straight line is working pretty good, then we don't need to use a curve because the straight line is good. So there's no reason to use a curve. So that's something that I hope you guys kind of learned today, something to take into consideration. If they're both looking very good, a 100% and a 100%, don't use the curve. Use the straight line. Use the linear. Okay, let's move it on. Let's pick up the pace a little bit. This one, I'll get my dots on there. I know you guys already have them. -3, 2, -2, -1, -1, -2, 0, -1, 1, 2. Hope your dots look like my dots. Hope they look like a nice U-shaped curve. Hope that makes you think, ooh, this is a perfect quadratic graph. Now here's tip number 2. On Desmos, I've already got my linear in there. I've already got my quadratic in there. Do I need to delete these?
Yes.
The truth is, I don't have to delete these. Instead of deleting everything out of here and starting over and having to make a table and write my linear and write my quadratic, I can leave all this stuff in here, and I can go to my table and I can press backspace. And if I clear out my table, what you'll notice is that these two equations empty out, and we get an error message, and it says, hey, the table's empty right now, dude. I can't make an equation off an empty table. And so you think, okay, now we're pretty good. So here's my recommendation. After every question, empty out this table, but leave these equations, okay? If you have to type this 15 times, you're probably going to make a mistake once, even me. But if you only have to make this one time, make sure it's good, and then just leave it there. So let's do number 2. -3, -2, -1, 0, 1. And the x values of 2, -1, -2, -1, 2. Okay? Now, because we left these in here, it's going to try to make us a line, and it's going to try to make us a curve. Now, we know for sure the curve is perfect. Look at this nice curve going through all the dots. I like my curve. It has a confidence of 100%. Look at the blue line. That does not look very good. Okay, the blue line has a confidence of 0. It is literally saying, hey, I know this is a bad idea. Please don't do this. So, with our blue line, we do not want to choose that. We do not want to choose the M. We do not want to choose the B. If you want, you can click this color blue, and you can turn it off. And now you don't have to look at it, which might be something nice for some people to do. And that way we can only look at the green, and we can get our ABC. Another thing that you can do is you can press the X. And if you press the X, it'll get rid of it. It won't confuse you. And you can always bring it back with the undo button. Right? So if you want to press the X, now it's not going to bother you at all. Now you can just use this, and at the end of the question, we can press undo, and we can bring it back. So here is our equation. Here is the ABC that we need. And maybe I'm going a little slow at this point. I hope you have the quadratic graph with the equation of y equals. Up first is the A, 1. And on that 1 is an x squared. And up next is the B, 2. And on that B is a single x. And up last is a C, -1. And on that C, no x's. Okay. Now again, if you deleted that linear line of best fit calculation, press the undo button, bring it back, and then delete your table, and we'll be ready to move on to the next question. All right, we have discussed 99% of everything we need to discuss. There's one more thing, and this is the #1 mistake, the #1 scare. I promise you, if I didn't say this, there would be somebody in this class who would panic on the test. So listen to me here. We have 2 equations. Both of them say y1. And we already talked about this y1. It says y1 because we have a table that has y1. And these need to match. Now, what will often happen is that there will be a person and they'll have this whole thing and they'll say, you know what? I don't want to backspace this table. I would rather just exit out the table. And I'll leave this stuff here I'll leave this stuff here. I'll just make a new table, plus table. And then they'll type it in. They'll say, you know, question number 3 is 1, 2, 3, 4, 5. And the y values, -5, -2, -1, -2, -5. And they'll hit the magnifying glass, and it'll look very, very nice. But they'll be thinking, I don't have the lines that I should have. I know it's quadratic, but my quadratic right here isn't making any sense. I don't have a r squared value. I have all of these weird parameters with the x1s and the y1s that shouldn't be there. So I'm sure you recognize by now, what is the mistake that I've made? The new table, when you make a new table, it shows up sometimes with the wrong numbers. So when I made a table here, this table showed up as a x3. And we have no matches here, right? Desmos is trying to make a y1 table, but there is no y1 table. So Desmos has no idea what's going on. So we need these to match. If you are thinking, my line is not showing up, Desmos is not working, I'm telling you, the problem is your table doesn't match your equation. We have y1, x1. We have y1, x1, x1. It's really easy to fix. You just press backspace 1. That's it. Go over to the y, and you just type backspace 1. And now everything is perfect. Now I have my lines. Now I can see that my quadratic looks perfect. My linear looks bad. So my recommendation, don't press the X on the table. It's going to mess you up. We don't want this line. We do want this quadratic. -1, 6, -10. That's easy. That's quick. I can do this question quickly. This is a quadratic graph. It is y equals a, -1x squared, b, +6x, c, -10. Right? It doesn't take super long. Again, of course, I don't have my pictures on here. You guys do, but 1, -5, 2, -2, 3, -1, 4, -2, 5, -5. Oh, I missed it. 5, -5. Okay, let's flip over to the back. Let's flip over to the back. Lord have mercy for sure. Now here's the good news. We're only doing 2 more questions. We're going to look at these bottom 2. We're going to look at 9 and 10. 9 and 10 are real life questions. We're getting away from just the plug and chug and do it over and over again. Number 9, if you're already finished, nice job. Let's make sure you got the right answer. Number 9 is talking about TVs. Or no, computers. The computers with time and value, which says TV. Sorry about that. Computer values. Computer values go down, right? You've all bought some electronics, and 2 years later, it is not worth a lot of money, right? Think about whether you buy a PlayStation. Think about whether you buy a car. The older it gets, the slower it gets, the cheaper it gets. So you can see, $1999, $800, $2000, $700. 2001, $600 is going down, down, down. Okay, let's get this data into Desmos and see what's up. I'm going to press backspace and not the X button. I'm going to get my data in there, 1999, the year 2000, 2001, 2002, 2003. Definitely follow along. I really recommend it. Don't just sit there staring at me. 720, 640. 572, 480. Hit the magnifying glass, and here we go. Now this looks a little confusing. Let me change one of these. Let me do maybe orange and purple. How's that? Orange and purple. We'll get some real crazy colors in there. So we have my straight line and my quadratic line, which is more of a curve than a line. Both of these have high confidence. The R is 99.84. Very, very confidence. And the R squared for this one is 99.85. Very, very confident. So we are super confident in both of these, something I told you 5 minutes ago. If you're confident in both, just use the linear, okay? If I hide both of these graphs, would you have guessed that this was straight or curved? You would have said that these were straight dots. You would have said a straight line could go through there. So you know what? If the straight is good enough, then just go with the linear, okay? I know this one dot is a little bit higher than usual. We don't need to do all this. Another good hint, if you look at the quadratic, you see where it says x 10 power 6? That is scientific notation, which you probably haven't even heard that word since middle school. We don't really want to do scientific notation. So this quadratic, I don't really like it. The linear is good enough. We can delete the quadratic for now if you want. We can always bring it back with the undo. I want to use the m and the b value. I know the b value is pretty large. I know it's a big number. But remember, this question is talking about 2000s. Right? So obviously the numbers are going to be big. We're working with linear because it's good enough. We're going with the equation, y equals negative 78.8 x plus 158,321. Sheesh, big, big number.
In fact, yeah, that's still ain't enough to buy a house nowadays.
So true, so true. Now, we still have one more piece here. When we did the notes yesterday, I put some money signs on here because this is where you make your money if you're trying to be a mathematician, if you're trying to be hired by Amazon or Google or Raising Cane's or whatever store you're trying to get hired by. We want to make a prediction for the 2008 value. So, what I'm going to do is I'm either going to set y equals 2008, or I'm going to set x equals 2008. It's going to be one or the other. Now, if I think about 2008, and I know that I used these values as my x and these values as my y, does 2008 work as an x value or as a y value?
X value?
It works as an x value, right? The x values, 2000, 2001, 2002, 2003. Guess what's coming up? 2008. So we don't want to use y equals for this question. We want to use x equals. A lot of people get super confused about this part. You just pick, it's either an x or a y, right? Look at the numbers. Does it fit in as an x number or does it fit in as a y number? So if x equals 2008, I'm going to zoom out just a little bit. Here's my line at 2008. And so here's the price of the computer. Down, 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 down. Here is 2008. How much is that computer going to cost? Click 90.8. And this is dollars. So it's going to cost $90.80.
Concerning the recession of 2008, I'm not surprised it would be that cheap.
All right. There's only a couple minutes before lunch. I'm going to do this last question. We're going to do it fast. We're going to try to do this whole question in about 2 minutes. Here we go. Delete the x there. I have my linear and my quadratic. Backspace my table. Backspace, 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 backspace. I'm now going to try to get the data in for number 10. 0, 1, 2, 3, 4. I'm now going to try to get the y values in. 305. 367, 397, 395, and 361. I'm going to hit the magnifying glass. Does this look curved or linear? Definitely looks curved, and obviously Desmos agrees. Really not confident in the linear, really confident in the curve. I don't need the linear. I'm going to work with the curve. Here's my equation, ABC. So I'm going to use those numbers. We're going with quadratic. And the ABC values over here are going to be used. So we've got y equals, first is the A, negative 16. That one gets an x squared. B, 78. That one gets an x. And C, 305. That one gets no x's. Now, they asked me a question. They asked me for a prediction. What is the height of the coin after 7 seconds? It's either going to be x equals 7 or y equals 7. If we're talking about the x values and the y values, 7 seconds, does that fit in with the time or with the height? It's the time. So we're going to use x equals 7. On Desmos, I'm going x equals 7. This is what's going on. I'm flipping the coin off the top of the Empire State Building, or what is it, Statue of Liberty. It goes up, 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 down, 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 down. And after 7 seconds, here it is, 67 feet in the air. Our answer is going to be, was it 67? 67. 67 feet in the air. All right, that is line of best fit. Remember, we learned today, just leave both these equations in there, okay? You can use undo to bring them back. Don't press the X on the table. Just use the backspace key to avoid getting our numbers mixed up. And take your time, right? Type things incorrectly, and it's really not that bad.